He believed that sensory signals travel to the brain through nerves, where they would cause a reaction like pulling a string that sets off a mission. Neural pathways. While Descartes' understanding of the nervous system was primitive compared to the modern knowledge, his idea that certain actions could be involuntary and automatic laid the groundwork for later research into the automatic nervous system and the study of reflexes. Influence on neuroscience. The concept of reflex acts. Descartes' ideas about the reflexes foreshadowed the later discovery of reflex acts, the neural pathways that underlie reflex actions involving sensory input, neural processing, and motor output. This concept is fundamental to understanding the nervous system and, and its organization. The behaviorism and the cognitive neuroscience. Descartes' ideas about the reflexive behavior influenced later developments in psychology, in cognitive science, and also particularly in behaviorism and behavioral studies, which focused on observable automatic responses to stimuli. This also set the stage for more detailed exploration of how the brain processes sensory information and initiates actions, a core aspect of the cognitive neuroscience. So, in the concluding part, Rene Descartes' contribution to the biological roots of neuroscience lie in his pioneering ideas about the mind-body relationship and the nature of reflexes. His dualism highlighted the distinction between mental and physical rhythms, a concept that continues to shape discussions in neuroscience and philosophy. His reflex theory, while mechanistic, anticipated future discoveries about the neural pathways and the automatic behavior. Although many of the Descartes' specific theories have been revised and refuted, his work remains a critical part of the history of neuroscience, influencing how we understand the brain's role in thought and behavior. The doctrine of specific nerve energies is a foundational theory in the history of neuroscience, developed by the German physiologist Johannes Müller in the early 19th century. This doctrine played a crucial role in shaping our understanding of sensory perception and the functioning of the nervous system. The concept behind the doctrine of specific nerve energies is the basic principle. The doctrine of specific nerve energies states that different sensory nerves are dedicated to carrying specific types of sensory information regardless of how they are stimulated. In other words, it is not the external stimulus itself that determines the nature of sensory experience, but the type of nerve that is activated. For example, when the optic nerve is stimulated, whether by light, pressure, or electrical impulse, the brain interprets the sensation as vision because that is the specific function of the optic nerve. Implication for sensory perception. Specificity of nerves. Each sensory nerve has a specific energy or the capability that determines the kind of sensation experienced. The optic nerve, for instance, is exclusively linked to visual sensations, while the auditory nerve is linked to hearing. subjectivity of perception. According to this doctrine, the perception is subjective and is more